13. Let's get it going. In terms of linear and nonlinear functions, that's what we're going to be talking about first. A linear function, no variable is raised to a power other than 1. So like y equals mx plus b. The value of x does not have an exponent with it. It's just 1. Where m and b are real numbers, meaning the slope and the y-intercept are real numbers. They could be any number. Linear functions can be represented by linear equations. So there's other forms of linear equations. You've got standard form, you have point slope form, but the most common one is slope intercept. The graph of a linear function is a straight line. Cool. This is stuff you know. That's amazing. All right. A function that is not linear is called this is not a big stretch, nonlinear function. The graph of a nonlinear function does not make a straight line. It includes a set of points that cannot all lie on the same line, so it doesn't end up making a straight line. A nonlinear function cannot be written in the form of y equals mx plus b. A parabola is a graph of a quadratic function, which is a type of nonlinear function. So for example, this would be like the most simple form of a quadratic function would be f of x is equal to x squared. If you have exponents, and you can't rewrite it without exponents, it is nonlinear. So, first thing we're going to do is determine whether each function is a linear function or not. Justify your answer. So, if you can write a function in the form of y equals mx plus b, where m and b are real numbers, which means they could be whole numbers, decimals, fractions, negatives, whatever, that makes it linear. So on this first one, it kind of walks us through the whole thing. So initially, this doesn't look like a y equals mx plus b equation. However, because we have a denominator of 3, that means that both the 6x and the negative 5 can be written separately with their own denominator of 3. You can pull apart a fraction. Because if you have something like 4 plus 7 over 11, that's the same thing as 4 elevenths plus 7 elevenths, because there was a common denominator to put those two things on the same numerator to begin with. So if you can put these together to make a common fraction, you can take a common fraction and pull it apart using the same denominator. Works both ways. Yeah, go for it. Go ahead and fill it back. So because we're able to do that, we can write this in y equals mx plus b form. You could leave it as a 6 over 3. That's still fine. But 6 over 3 is 6 divided by 3, which is 2. So you can write it as 2. So f of x equals 2x minus 5/3. Y equals mx plus b. So the function can be written of the form f of x equals mx plus b. So it is a linear function. Does this seem more straightforward than lesson 1? Hopefully a little bit. All right. Now the next one, I think this next question is actually a little bit easier. Just because you've got an exponent of 3 there, and there's really no way to get rid of your exponent of 3. And so all it's doing here is it's using the commutative property, which says you can reverse the order of addition. So we're going to have 3x cubed, 5y equals 3x cubed plus 4. Even if you get y by itself by dividing both sides by 5, you're still going to have an exponent of 3. You can't rewrite this without an exponent. So the function cannot, or can't, be written of the form y equals mx plus b, because the independent variable x is raised to a whole number power greater than 1. That's what they're looking for there. So it is a nonlinear function. There we go. So that's the idea of linear and nonlinear. You can use a little bit of algebra. If you can get y by itself and you got y equals some number times x plus or minus another number, it's linear. If it can't be written like that at all, it's not linear. You don't necessarily have to go through all this work either. Like this one right here, we can look at this one and be like, oh, there's a cube there. Is there a way to get rid of that cube? No. Okay, it's not linear. You can just go ahead and answer that right away. Questions before we move on? Cool. Let's take a look at the next one. Determine whether each graph represents a linear or nonlinear function. Well, for A, there is no straight line that will contain the chosen points A, B, and C. So basically, here's A, here's B, here's C. If all 3 points appear in a straight line, that makes it linear. If all 3 points do not appear in a straight line, it is nonlinear. So, linear or nonlinear? Nonlinear, all right. Cool. How about B? Yeah, all 3 points are in a straight line, therefore linear. Represents a linear function. Yay, all right. Let's go to the think about it real quick up on the top left. Why is f of x is equal to the square root of 2x plus 3 not a linear function? Is x by itself? Not really. Where is it? It's with the 2 and it's underneath square root. So it's not x by itself. Now, if it was like the square root of 2 times x plus 3 like that, we'd be good. Because the x would be by itself, not underneath the square root. If the x is underneath the square root, it is not linear. If it's outside the square root, it's just x, we're good. So yes, linear, no linear. I think we got time for one more. Like I said, this should be a much quicker lesson than what we had last time. Identifying linear functions from tables. All right, so Michaela has started working a part-time at the local hardware store. Her time at work steadily increases for the first 5 weeks. The table shows her earnings for each of those weeks. Are her weekly earnings modeled by a linear or nonlinear function? Well, we get to plot the points. If they appear in a straight line, it's linear. If they do not appear in a straight line, it's not linear. So week one, $85. So let's see, 85. That would be 100. So wow, that's going to be like right there, like just above the 80, because these are separated by groups of 40. So these are going to be estimates of where these points are. Week 2 is 119. So like barely underneath that line there. Week 3 is 153. Let's see, that'd be 140, 153 is going to be maybe about right here-ish. All right, and then week 5, oh, that's not week, yeah, 153, 187, 160, 187, so a little bit more than halfway between those two there. And then 221 would be about halfway in between those. About like that for week 5. So, since there is a straight line that contains all the points, Michaela's earnings can be modeled by a linear function. So this does end up being linear. By the way, you can also tell this by figuring out the differences. So you can take 119, subtract 85, and you'll get a number. You can take 153 and subtract 119, get the same number. You take 187, subtract 153, you get the same number. Same thing with the last two. So you do not have to keep the paper I handed back. Just, I would always recommend double checking on PowerSchool just to make sure it's accurate, and then you can do whatever you want with it. All right. We will finish this up tomorrow.